Hello, everybody. I hope everybody's doing all right. Trying to make a video. I don't know how successful this will be, but we'll see what we can do. Um, let's see, I'm gonna try to put this down here out of the way. I may have to get rid of that. All right, so I'm gonna do a little quick PowerPoint. This won't take very long. I just want to kind of talk a little bit about graph and sinusoidal functions. I had some questions about that, so we'll see what we can do. Hopefully, this will work. Anyways, here's a quick little PowerPoint about graphing sinusoidal functions. Basically, we first want to talk about the anatomy. So I'm going to move this up here out of the way. The anatomy of a trig function. So here's your general form of the trig equation. Y equals A times trig function, parentheses B, parentheses X minus C, close all those parentheses plus D. The amplitude is A, so that's something we've already learned from the last week's lessons. You all tend to do pretty good with that. And plus, we talked about that also before in class, right before the ACT. The day right before the ACT, we talked about amplitude and period. So the period is 2 pi divided by b, unless it's a tangent or cotangent function, and then the period is pi divided by b. I'll put this PowerPoint on Google Classroom too, by the way. The value C will shift the function left or right, which is a horizontal shift. This is also called a phase shift. The value D, let me move this. No, I want to go back. So it's kind of low on the screen here. Okay, whatever. The value D, we'll go back into the PowerPoint here in a minute, but the value D will shift the function up or down. That's a vertical shift. And I think that's what some of you are dealing with when you first start doing some of this assignment for this week. So let's talk about midline with the vertical shift. So I'm just going to talk about vertical shifts right now. I will try to do another video of phase shifting later. But the line that a sinusoidal function is centered on, that's the midline. The function keeps moving up and down and intersecting the midline ever so often. The default midline is y equals 0. This changes when you have a vertical shift. For example, this function, y equals 3 sine of 2x plus 1. The amplitude is 3. That should be a 3 there. Notice I made a mistake. I made this so quick that I made a little mistake right there. So we're going to fix that. That's all right. We're nobody's perfect. So going back in, the amplitude is 3. Now that we fixed that little mistake there, the period is 2 pi divided by 2, which is pi. And this function has a vertical shift of up 1. So that's because of the plus 1 right here. Notice, see the plus 1 right here? That plus 1 signals that the function is being shifted up 1 unit. So instead of the midline being at y equals 0, like it normally is, the default midline, now it's going to be shifted up 1, so the new midline is now y equals 1. So when you're doing the problems on the assignment, let's go to an example problem. Let me scroll down. So the function here, we've got y equals 2 sine of pi over 10 quantity times x. That's all in parentheses minus 7. So this has been shifted down 7. So the very first thing I would do, honestly, I'd take care of the midline if I was you. So it's going to be shifted down 7. So I'm going to move this starting point. And guys, basically sine and cosine functions, you're moving your starting point with your vertical shift. Sine always starts on your midline. If you've noticed that, the pattern with sine, really when you look at sine and cosine curves, they don't look a lot different. But if we were graphing this on paper, you would start with the midline. Sine starts on your midline. Cosine starts above or below your midline, depending on whether the value A is positive or whether it's negative. And you start that many units, whatever the amplitude is, above or below that midline. So hope that helps. So I'm just going to shift this down a little bit so it doesn't look so crazy right now. So I got to figure out where to shift this now. We've got the midline right here. It's y equals -7. That comes from the -7 right here. So the amplitude is 2. So I know I'm going to go up to -5 and I'm going to go down to -9. So actually I've got it set right as far as the amplitude. So now I just got to maneuver this point side to side until I figure out the period correctly. So we take 2 pi divided by this quantity, pi over 10. Okay. That means we have to stay, change, flip. So 2 pi times 10 over pi. The pi's will cancel out and you get 2 times 10, which is 20. Hope you followed that. It's a little hard to show that here. Maybe I'll figure out a tool to be able to use to help with that. But anyways, hopefully you follow that. 2 pi divided by pi over 10, stay, change, flip, stay 2 pi over 1 times, because you change multiplication, and then you flip pi over 10. Your pi's will cancel out and you'll get 20. So if my amplitude or my period is 20, this point right here needs to be, this first maximum needs to be, basically, if I'm going to start here, the function is going to go up to the maximum. It's going to come back down through the midline, down to the minimum, and it's going to come back up. And over here, this should be 20 away. So it's obviously not 20 away right now. So this point right here, it needs to be a fourth of the distance away from there, because a fourth of the distance of the period. The period is as a measurement of x. Amplitude's a measurement of y. So period's a measurement of x. Get my hands right here, okay? Period is a measurement of x, side to side. Amplitude's a measurement up and down. So if my period is 20, the distance from my from my starting point to my first maximum should be a fourth of that, because then the next fourth will be down to the midline again, whatever x distance that is. And then the next fourth of it will be down the x distance it takes to get down to the minimum. And then the last one will be back to the midline where the pattern starts again. So a fourth of 20 is 5. So I'm going to move that point to 5. And then I'm going to check my answer. And I'm going to get that one right. And I don't know why it's telling me that, because I haven't done this assignment. So hopefully that helped with that. If it's asking you different questions, just let me know, because it does kind of do some weird things sometimes. Hopefully that worked. Here's another example, just to show one more example real quick. So this one's got a vertical shift of up 4. So I'm going to move that starting point up to 4. It is a sine function, so it's going to start there at the, it's going to start right here. Okay, we're not phase shifting anything just yet, because this doesn't have any C values in here. It doesn't have like a -4 or minus whatever. Okay, so then we're going to shift this. I'm going to just move this one up so it looks normal. So my amplitude is 3. So from 4, I'm going to go up to 7. And it's going to go down 3 from 4. It'll go down to 1. So see that once you change a vertical shift, you're going to change where your points are, where depending on your amplitude, where your maximums and minimums are. But it still should be the amplitude is the distance from your midline up to the maximum, or from the midline down to the minimum. Hopefully that helps make sense there. And then my period will be 2 pi divided by 1/3, which stay, change, flip, you get 6 pi. So 6 pi, so this first point right here should be a fourth of that distance. So when I take and divide 6 pi by 4, I get 3/2 pi, which is 1.5 pi. So that should be where the point goes. Check my answer. I've got the right answer. Hope this helps. See y'all later.